Hey, welcome back, folks. Today we're going to do a video on adding calcium carbide plus water. We might even light it on fire just a little bit. So what we have today is we have some calcium carbide. We're going to add it to water. It's going to react to form acetylene gas, which is pretty explosive, and calcium hydroxide, which is a solid. So come over here. We've got our setup here. We've got just a petri dish, a glass petri dish, and we're going to take some just regular deionized water. Any water works. We're going to add that to the dish. A little bit there. It's not the very fastest squirt bottle in the world. Sorry about that. Then we're going to take some calcium carbide. Now, this calcium carbide looks like this. It is a solid, almost looks like rocks. Oh, as I got some in there accidentally. We're going to actually just add that right now. You notice that it is bubbling. It's forming a white solid precipitate. There's actually a lot of heat given off too. It's pretty warm. And I see some gas floating off of it too. Yeah, a little bit more water here. There's definitely gas bubbles given off as it reacts. It reacts very violently. Very violently. We add just a little bit more to it. I'm going to do something different this time. This time we're going to light it on fire. And these bubbles actually are burned. They're very explosive bubbles. They burn so fast they won't stay lit. If you were to catch this gas and put it in a beaker, it would blow up. I don't know if you notice there's smoke particles. That's the acetylene burning. Now, the reaction is twofold. The first part is just reacting with water, and the second reaction is burning it. I just burned it for fun. That's not even part of what you're supposed to write down. It's just sort of fun to burn this stuff. Very reactive. Much more reactive than, let's say, alcohol. This is also the gas that we use in torches. It can actually gets hot enough, if you mix it with pure oxygen, it will cut right through steel. That's how hot it is. I don't know if you see how these little floaty things floating around here, but it sort of makes a mess. It really stinks. I've already had some complaints this morning of, hey, quit stinking up the building again. That's all right, though. I like stinking up the building. Hey, so let's go over to the board again. So what just happened is we had calcium carbide, CaC. It's a solid, and it reacts with H2O, liquid water, 2 of those, and it forms this guy right here, acetylene gas, C2H2 gas, and it also makes a white precipitate of calcium hydroxide. Could put that aqueous. It could also be a solid, sort of fine enough that it's pretty much a white solution. That's why I have it listed as aqueous there instead of just a solid. Now, before we did this, the physical properties of calcium carbide is a solid. It's gray. It feels very much like rocks. Liquid. It's a clear liquid. And the chemical properties of calcium carbide is reactive with H2O. It's got a very high energy content to it. Even with water, we think of water. I didn't put any chemical properties of water there because we just assume water is pretty tame. But when you get it with certain things such as calcium carbide or sodium, it will react quite violently. Now, when we're all said and done, what is formed is acetylene gas, which has a different physical property. It's in the gas state, floats up. It's what causes the bubbles in there to form. And also the calcium hydroxide, which is the white powder or aqueous solution that is left over. And the chemical properties is acetylene gas is very reactive. So it goes from very reactive to still very reactive, but we change the water into now calcium hydroxide, which is a base, which is more reactive. So I would say calcium carbide is more reactive than acetylene. Loses just a little bit of that energy into the calcium hydroxide. A little bit of that energy has gone into changing the water into just a little bit more energy. But acetylene gas, like we saw, still is very, very reactive. But the calcium carbide is extremely high energy and reactive. For a rock looking, it's very, very misleading. When you throw it into water, it just about blows up. So evidence of a chemical change occurring. Well, we have a new substance is formed. Now, that's the end of that. We have a new substance formed, acetylene gas and calcium hydroxide. Now, if we go one step further, we can burn it and oxidize it just to prove that gas actually was acetylene gas. But technically, that's a second reaction, and so is that. So we really just have formation of a precipitate, heat given off, and a new substance formed. And maybe we'll write down the burning of that as a different chemical reaction. But just evidence of a chemical change for calcium carbide is a new substance. It gets hot, the heat's given off, and formation of, I forgot to add a word right there, of precipitate. So hope you've enjoyed this video. Go ahead and fill out your worksheet and move on. Thank you. Bye.